Section 2.1 is on complex numbers. Now, unfortunately, this is going to be probably one of the only times that you're going to encounter complex numbers in many of your math courses, at least at the community college level. But they are quite important. And you might run into them, say, if you take engineering or physics. And here's the funny thing, even though they're called imaginary, they are found in reality. All right. So what is an imaginary number? Well, an imaginary number is I, right? We call I the square root of -1. And the whole point of doing this is because we run into situations where we have square roots or fourth roots or something like that, right? Even index roots that have a negative radicand, which means, say, let's do the fourth root of -8 or something like that. Right? This we can't handle unless we use I. Now, I times itself, right? I times I is I squared, and that's the square root of -1 times the square root of -1. And we all know that the square root of something times itself gives back what's in the radicand. I cubed, right? What does that look like? Well, we could do I times I times I, and I times I is -1. So that's -1 times I, or negative I. And then I to the fourth, well, that's going to be, right, I times I times I times I, or -1 times -1, which is back to +1. And with these four, we can calculate any power of I. So that's the imaginary number. A complex number is a number written as A plus BI. That's standard form. And A and B are real numbers. So A is just a constant, and then some number times I, which is your complex part. So some of the things we're expecting to be able to do here are manipulations with these. So addition, subtraction, multiplication, and division. And then solving quadratic equations that have solutions with complex answers. So first, we're going to add and subtract complex numbers. So how do we go about doing that? Well, we just need to combine like terms. So here we've got two complex numbers in parentheses. We can drop the parentheses. Then we can group like terms. So I'm going to regroup them as such. So now I have all the constants together and all the I terms together. And that's going to give me 7 plus 3I. All right, well, that was pretty simple. What happens if we put a minus, right? If we subtract two of them? Well, just like previous examples where we've had this situation, not with complex numbers, you just need to distribute the negative. So we have 3 minus 7I minus 16 plus 13I. Again, grouping like terms. All right, so I have 3 minus 16, so it's going to be minus 13. And then I have 13I minus 7I, that's going to be 6I. Okay. Now, typically you want A to be positive, so we could factor out a negative out of this. And we could write it this way, but it doesn't have to be. Next, we're going to look at multiplication of complex numbers. This is going to work just the same way as polynomial multiplication. The only difference is that when we have I times I, right, we can rewrite that with the terms that we had learned previously. So let's go ahead and take a look at a few of these. This first one here, we're just going to distribute 2I. So this would be 2I times 5 plus 2I times 2I. 2I times 5 is going to give me back 10I. and then 2 times 2 is 4, and then we have I squared. Now we don't want to leave it this way. We want to go ahead and substitute for I squared. So I squared is equal to -1. So we end up with a complex number. It is -4 plus 10i if we put it in standard form. Right, so that was a monomial times a binomial. What if we have two binomials multiplied together? So here I'm going to do 7 times 2 and then 7 times 4i, right? I'm just doing FOIL. 7 times 2 is 14. 7 times 4i is going to give me 28i. Then -3i times 2. So that's going to be -6i. And then -3 times 4. That's -12. And then I times I is I squared. So here we have like terms. We can combine these. So this would be 28 minus 6, or 22i. And then for I squared, we're going to again plug in -1. So -12 times -1 makes it +12. And then we can add that to the 14. So 14 and 12, that's 26. Again, writing this in standard form. Now, both of those are divisible by 2, so we could take a 2 out technically. All right, we can make this 2 times 13 plus 11i if you wanted to write it that way. All right, here's another example. We have 6 minus 3i all squared. We all know how to do FOIL, right? It's 6 minus 3i times 6 minus 3i. I'm going to once again use that shortcut. Remember that a plus b, or a minus b squared, is a squared plus or minus 2ab plus b squared. Okay. So first term squared is going to be 36. Then it's keep the sign. Then 6 times 3 is 18 times 2 is going to give me 36i. And then -3i times -3i, that makes it plus 9i squared. But we recall that I squared can be substituted for. And that can be -1. So we end up with 36 minus 9 minus, oops, 36i. Okay. And 36 minus 9, it's going to give us 27. Again, those are both divisible by 9. So I'll factor out a 9. It'll look like that.